Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving the modulus function, right? So here we have to find the value of this integral from 0 to pi by 2, and the integrand is sine of mod of 2x minus a, where a belongs to this closed interval 0 to pi, right? So here we see that we have this mod function that is mod of 2x minus a, right? So let us start. So here we'll make use of a very important method of integration, that is substitution method, right? So let us call this integral as I, and here we'll make use of the method of substitution. So let us take t is equal to 2x minus a, right, where a is a number which belongs to this closed interval 0 to pi. Now differentiating t with respect to x, we have dt over dx is equal to 2 times 1 minus 0. Because the derivative of x is 1, the derivative of a is 0, being a constant, right? So this is 2. So dt over 2 is equal to dx, right? Because from here we can write dt is equal to 2 dx, and dt over 2 is equal to dx, right? Okay, now whenever we use the method of substitution, we always change the limits, right? So here the lower limit is 0, the upper limit is pi by 2, and since by method of substitution we are introducing a new variable t, so here x varies from 0 to pi by 2, right? So let us find the corresponding value of t. So when x is 0, then the value of t is 2 times 0 minus a, that is minus a, right? So here we'll substitute x is equal to 0. Now when x is pi by 2, the value of t is 2 times pi by 2 minus a. So this 2 and this 2 get cancelled. So we are left with pi minus a, right? So when x goes from 0 to pi by 2, then t goes from minus a to pi minus a, right? So now this integral I can be written in terms of t as minus a to pi minus a, and here we have sine of mod of t, right? Because 2x minus a is t, and for dx we can now write dt over 2, right? We can take half outside the integral, so we have minus a to pi minus a, and here we have sine of mod of t dt, right? So viewers, now we have this integral to evaluate. Now see, here what we will do, will make use of the definition of mod function and one important property of definite integrals. Now see, we know an important property of definite integrals, that is integral from a to b f of dx can be written as a to c f of x dx plus c to b f of x dx, right? When c, it lies between a and b, right? So this property shall be used here. So before applying this property, let us see the definition of mod function, right? Now see, mod of t is defined as positive t whenever t is greater than 0, right? Mod of t is 0 when t is equal to 0, and mod of t is minus t whenever t is less than 0, right? So now what we will do, we'll write this integral as a sum of two integrals, right? So the first one goes from minus a to 0, right? From minus a to 0 we have sine of mod of t dt, and the second one is from 0 to pi minus a, and here we have sine of mod of t dt, right? So we have written this integral as a sum of two integrals, and this value, that is this point 0, it lies between minus a and pi minus a. Now see here, this point is 0, it lies between minus a and pi minus a, right? See, a belongs to this interval, that is 0 to pi. Now let us take a is equal to pi by 2 as an example. Then we can see that we have minus a. So minus a is minus pi by 2, right? And what is pi minus a? Pi minus a is pi minus pi by 2. So this is 2 pi minus pi over 2, that is pi by 2, right? So it means we have to integrate from minus pi by 2 to pi by 2, right? So between minus pi by 2 and pi by 2, we have the point 0, right? So we go from minus pi by 2 to 0, and then we go from 0 to pi by 2, right? So that's why we have written this interval as a sum of two integrals, and 0 is the point where we have split this integral into two parts. So now let us take this integral as I1 and this integral as I2, right? So I is now equal to half, and we have I1 plus I2, right? So we'll separately solve I1 and I2. So I1 is integral from minus a to 0, right? And we have sine of mod of t dt, right? Now see, here we have minus a to 0. So all the values are negative because t, it goes from minus a to 0. Now see, here we have 0 and here we have minus a, right? So all the values which lies between minus a and 0 are negative, right? So when t is negative, then mod of t is equal to negative of t, right? So mod of t is minus t when t lies between minus a and 0. So we have now minus a to 0, and here we have sine of minus t, right? Because mod of t is now replaced by minus t. Now from trigonometry, we know that the sine of minus theta is equal to minus of sine theta, right? So this is negative of minus a to 0 and sine t dt, right? So sine of minus t is minus sine t, and taking this negative sign outside the integral. Now integral of sine t is minus cos of t, right? And the limits are from minus a to 0. So this negative and this negative becomes positive. So we have cos of t, and the limits are from minus a to 0. So this is cos of 0 minus taking t is equal to 0 and then taking t is equal to minus a. So we have cos of minus a. So cos 0 is 1, and here again from trigonometry we know that cos of minus theta is equal to positive cos theta, right? So cos of minus a is simply cos of a, right? So the value of I1 is equal to 1 minus cosine a. So now let us take I2. So I2 is integral from 0 to pi minus a, right? And here we have sine of mod of t dt, right? Now see, here t, it goes from 0 to pi minus a, right? So let us see this interval, that is closed interval 0 to pi. Now here a belongs to this interval, that is 0 to pi. So we can now write a is less than or equal to pi, right? From this interval, right? Because a belongs to this interval. So a is either less than pi or equal to pi. right? Now if we multiply this inequality both sides by -1, then we have minus a is greater than or equal to minus pi, right? So here we have left this 0. We are only considering this pi, right? So now adding both sides pi, we have pi minus a is greater than or equal to minus pi plus pi, because adding pi to both sides we have pi minus a that is greater than or equal to 0, right? So it means pi minus a is greater than or equal to 0. It implies that it is positive, right? So when t is positive, that is t is greater than 0 or t is equal to 0, we have mod of t is equal to t, right? So now I2 is 0 to pi minus a, and here we have sign of simply t, right? So mod t is equal to positive t when pi minus a is positive. So now the integral of sine t is minus of cos t, and the limits are from 0 to pi minus a. So this is, we can take negative sign outside. We have cos of pi minus a, and then we have cos of 0, right? Substituting the limits and taking the difference. Now from trigonometry, we know that cos of pi minus theta is equal to negative of cos theta, right? So we have minus cos of a, and cos 0 is 1, right? So minus minus becomes plus here. Similarly here also we have plus 1, right? So the value of I2 is 1 plus cos of a, right? So now the total value of I is half, and we have I1 is 1 minus cos of a, right? And I2 is 1 plus cos of a, 1 plus cos of a. So cos a and cos a get cancelled. We are left with 1 plus 1, 2. So I is half times 2. So 2 and 2 get cancelled. So we are left with 1, right? So the value of this integral is equal to 1, right? So viewers, this is how, by making use of the concept of mod function and the properties of definite integrals and other important results from algebra, we can solve these type of integrals. Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving the important function in mathematics, that is modulus function, right? So we have already uploaded these kind of problems in our channel, but here we'll discuss one more problem, right? So here we have to find this integral that is from -3 to 4, and the integrand is mod of 2 minus x, right? So these problems are very important, and particularly this problem is very useful for the beginners, right? So let us start and let us see how the definition of mod function can be applied to this function that is mod of 2 minus x, and how we can split this integral as a sum of two integrals, right? So let us start. So viewers, let us first quickly revisit the definition of absolute value function, which is also known as mod function, right? So mod of p is defined as positive p whenever p is greater than 0, right? And mod of p is 0 whenever p is 0, and mod of p is negative of p whenever p is less than 0, right? Now here our integrand is mod of 2 minus x, right? So let us take f of x as mod of 2 minus x. So if we take p as 2 minus x, then see how mod of 2 minus x can be defined. So mod of 2 minus x is now positive 2 minus x, because p is 2 minus x, and 2 minus x is greater than 0, because here p is greater than 0, and this is 0 when 2 minus x is equal to 0, and this is negative of 2 minus x whenever 2 minus x is less than 0, right? So now we can rewrite this definition as mod of 2 minus x, and here we have 2 minus x, and 2 minus x is greater than 0, right? So if we solve this inequality, we'll get minus x is greater than minus 2, taking this 2 to the right hand side and multiplying both sides by negative 1, we get x positive 2, but the direction of the inequality get reversed, right? So when x is less than 2, we have mod of 2 minus x is equal to 2 minus x, right? And here we have 0, 2 minus x is equal to 0. This is a linear equation, so x is equal to 2, right? And here we have a negative of 2 minus x, so this is minus 2 plus x when 2 minus x is less than 0. So again, solving this inequality, we have minus 2, taking this positive 2 to the right hand side, multiplying both sides by minus 1, we get positive x. Here we get positive 2, but the direction of the inequality get reversed, right? So here we have x greater than 2. So now we have mod of 2 minus x like this, right? So now once we have defined mod of 2 minus x, let us take care of the limits, right? So the lower limit is minus 3 and the upper limit is 4. So here we have minus 3 and here we have 4, right? And see, here we have mod of 2 minus x. So if we solve 2 minus x is equal to 0 as we have done here, then we have x is equal to 2, right? So here we have 2, and we see that this 2, it lies between minus 3 and 4, right? Okay, now see, mod of 2 minus x is equal to 2 minus x when x is less than 2, right? So in this part we have x less than 2, right? And x is equal to 2 is the point itself, that is 2. And when we have x greater than 2, then we have this part, right? So from 2 to 4 we have x greater than 2, and when we consider minus 3 to 2 interval, then x is less than 2, right? So when x is less than 2, then mod of 2 minus x is simply 2 minus x, right? And when x is greater than 2, then mod of 2 minus x is minus 2 plus x, right? So now we can take this integral as I, and we can split this integral as a sum of two integrals where the breaking point is 2, right? So x is equal to 2 is the breaking point. So I1 is from minus 3 to 2, and we have mod of 2 minus x dx, and then I2 is from 2 to 4, 2 to 4, and we have mod of 2 minus x dx, right? Okay, so now we have minus 3 to 2, and when we go from minus 3 to 2, x is less than 2, so mod of 2 minus x is 2 minus x. So mod of 2 minus x is replaced by 2 minus x. Okay, now here we have 2 to 4, and mod of 2 minus x is now defined as minus 2 plus x, right? So now this integral is divided into two parts, the first one and this is the second one. So now I1 is this integral, minus 3 to 2, 2 minus x, and this is 2x minus x square over 2, and the limits are from minus 3 to 2, right? Because here we have 2 minus x dx, and this is 2 dx minus x dx. So the integral 2 dx is simply 2x, and integral of x dx is x square over 2. So now let us substitute the limits here, and we'll take the difference. So first we'll take 2. So this is 4 minus 2 square is 4 over 2, that is 2. And here we have minus 3 times 2 minus 6. Then we have minus 3 square is 9, 9 over 2, right? Okay, so this is 4 minus 2 is 2. This is 2 6 are 12. 12 minus 9, minus 12 minus 9 is minus 21 over 2. So this is 2 plus 21 over 2, that is 2 to the 4 plus 21 over 2. So this is 25 over 2, right? So the value of I1 is 25 over 2. Let us calculate the value of I2. So I2 is 2 to 4 minus 2 plus x dx, right? So as we have done in I1, here we have minus 2x, then we have the integral of x as x square over 2, and the limits are from 2 to 4, right? So first we'll substitute 4 for x. So we have 2 4s are 8. 4 square is 16 over 2, that is 8, because 16 divided by 2 is 8. Then we have 2, this is minus 4. Then we have 2 square is 4 over 2, that is simply 2. So this is 0. 8 minus 8 is 0, and here we have minus 2. 2 minus 4 is minus 2, so this is 0 plus 2, that is 2, right? So the value of this integral I2 is 2, right? So the overall value of I is calculated by summing these two integrals I1 and I2. So I1 is 25 over 2, I2 is 2. So this is 25 plus 2 to the 4, 4 over 2. Then we have 29 over 2, right? So viewers, the value of this integral is 29 over 2.